Hello, good evening, friends. Today we are going to move ahead with our last week's lecture, and we will go ahead to talk about something about logarithm. Before we launch something about logarithm, uh, it is pertinent to mention here that what is domain of a function. Obviously, we will talk a lot more about function at later stages when the time comes, and we will deal with a lot on functions at a later stage. But before that, an introductory version on function. So what is a function? Function fx is a relationship between an input and output. So pictorial representation of which is summarized as below. Like if we have a box here which is f of x, and we give an input x and we get an output y, so y is equal to f of x. This is the definition. So primarily we are dealing with a function that translates x to y. So how x gets translated to its output, that relationship is called fx. So you might have, so basically elementary level, at the very elementary level, let us assume we have a function defined f of x is equal to x square. So essentially that means if we input y, x is equal to 1 as input, then y so if we have a x here and y here, so f of x square is defined as, if we input 1 we get output 1, because 1 square is equal to 1. 2 of square is, if we input 2 we get 2 square, that is 4, and so on. Let's say 10, we get 10 square is equal to 100. So this is all about a x translated into y, and the set of all these numbers loosely called is domain of x. So domain is very important and key concept to remember here before we delve more into this logarithms. So y is what? Y is known as a range of function. So what is range? Let's assume another function f of x is equal to sine x. So naturally we have a range, a domain here. Domain is a range of x for which fx is defined. Defined is a fancy word to understand where this fx is valid. Validity, in short, 1 by 0 is invalid number. You are not defined. Obviously sometimes it is said near infinity, but this is my elementary understanding of this. And the range of values sin x takes is range. Range is range. This is the value, the set of values. So this is all about elementary understanding of domain and range. We will obviously cover it in detail at later stages. We don't have to worry about that. So coming back to logarithms. Logarithms. So what is the log of a number? Let's assume we have a relationship ax is equal to y. We have got this relationship. So a defining log is log of y by a is equal to x. This is the relationship. In short, a moves here and x is pushed upwards. So that is the kind of relationship logarithm and this functions have. So essentially, if we got 2 raised to power 3 is equal to 8, which is very evident, 2 multiplied by 2 multiplied by 2 is equal to 8. So while you take log on both sides, so log of 2 by 8 is equal to 3. This is again, if you want to come backwards, 2 will shift here and 3 is pushed upwards. So 2 raised to power 3 is equal to 8, which is what is very evident, and this relationship is true. So now a very elementary question. Calculate logarithm of 6 216 root 6. So how do you solve this number? So essentially you can take a bracket here. So y is equal to log of 6 206 root 6. So it is a multiplication in between. So you can, since log of a into b is equal to log of a plus log of b, so you can go ahead and calculate this as plus log of 6 root 6. Now second term, log of 6 and 6 to the power half as root of x is equal to x raised to power half. So coming back, another relationship, log of a to the power x is equal to x of log a. So this half will move here and log of 6 into 6. So this is log of a is equal to 1. So this will be half into 1. And this is 6 of cube. So log of 6. So this is 3 log 6 into 6. So 3 again, this will be 1. So 3 plus 1 by 2. So this is 7 by 2. So this is a very basic, indeed a very basic example of a logarithmic system. You have to break it down to known principles of logarithms and properties. Again, another example, solve log 927 minus logarithmic of 27 log 9. You can see it is very easy to judge. This is 3 raised to power 3 and this is 3 raised to power 2. So coming back, log of 9. So since we have this, to make it in a familiar term, what you will do is you can do a shortcut here, like this is 9 into 3, so obviously log of, let's assume for a moment that log of 927 is called x, let's assume here, and so again 9 raised to power x is equal to 27. This is a relationship you will get, and 3 raised to power 2x, because 9 can be written as 3 raised to power 2x, breaking it down, this is 27 again, so you will get this is equal to 3 into 3 into 3, so essentially 3 raised to power 3, so exponents 2x is equal to 3 and x is equal to 3 by 2. So this is the relation, and again this is, since this is can be converted into this log of 9 by 27, and now this has already been solved here, you can substitute it and you will get the result as 3 by 2, since this is inverse 2 by 3, 3 cross 3 9 and 9 minus 4 6, so this is 2 by 6 is equal to 1 by 3. I might have made a mistake, so 9 minus 4 is 5, sorry, so this is 5 by 6. So this is how you deal with this problem. Now again another example. Solve. Logarithmic of 2, logarithmic of 2 again, and again logarithmic of under root 2 and 256. This is the question. So essentially take this as x to solve. So log of root 2 256 is equal to x. Again you will shift this root 2 to here, so what the relationship will be, root 2 raised to power x, this will be converted into 256, so 256 is 2 raised to power 8, and root 2 can be written as 2 raised to power half, and to the power x is equal to 2 raised to power x by 2, hence x by 2, equating these exponents, x by 2 is equal to 8 and hence x is equal to 16. So this is what you will get. So this expression will be converted into this. If we take this as y, then y will be converted into log of 2, then logarithmic of 2. And now since you have already solved for x, so then it will make your life a bit easier. Again 4 can be written as 2 raised to power 2, so again log of 2 is 2, log of 2, again log of a is equal to 1, so this is log of 2 base 2 again, so the answer will be simplified. So this is, oh sorry, here I have made a mistake here again. This is 16, so 2 raised power 4 here will be, and this is 4, 4. Hence answer will be last, when you solve it you will get 4. Moving on to another example. So basically how much you practice is a lot to do with the expertise. So some properties of logarithms will come handy in competitions, so make a note of it. It is very urgent. So log of base xa and log of base x of b is equal to log of x a into b. This is a one property which we have used in the previous examples. Similarly, a corollary of this is log of xa plus log of xb. Sometimes series problems come where you have to make use of this dot 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 z. This is one exam property which is very relevant. Now log of x a minus of log of x b, you can write it down as log of x a divided by b. 3 log of x is 1. Fourth is log of x 1 is equal to 0. Minute transformation x raised to power 0, where you push this x here and x is pushed to this exponent, 0 is pushed to the exponent. It is very clear that x, any number raised to power 0 is equal to 1. So that is a very self-explanatory kind of a property. Log of a b is equal to 1 divided by log of base b divided by a. So this is another property. And change of base, this is a very tricky property, but you have to take some bases, change base sometimes to solve a problem. We will see it, don't worry about later. So this is how change of base is done. This k is an arbitrary base, but it will come naturally to you when you solve some kind of problem. Until unless specified, log of a is a base 10. If it is not implied, you automatically assume a 10 until unless you are solving a calculus problem. Calculus, we will delve into it later. Until you are solving a calculus problem, where this base is logarithmic base. Base E. We will explain it later. We'll come to it. So nothing to worry about it as of now. So another property, log of a p to the power q we have seen it, is equal to q log of a p. We have just solved a couple of problems before this, and another problem, log of a b to the power x, where bit of a to the power b of x, where this is in the base, so this is 1 by b log of ax. This is a important property. You can solve it here. If we push it, x is equal to, so a to the power b whole to the power, let's assume a bit of jugglery here, and you will be able to solve it. Let's assume log of a to the power bx is equal to y. Then if we push it here, x is equal to a to the power b to the power y. So taking log of both sides to the base a, log of ax is equal to log of a to the power b to the power y. Hence this is y log a to the power b, and so shifting that you will get this relationship. Another example is so let's assume you have to solve problem log of a b plus multiplied by log of ab multiplied by log of ac multiplied by log of ad. So we have to use this base change formula. As I said, you will be needing it. So let's assume we take a base of log. How do you write it? This is because so I have written a problem wrong. Log of b to the power c log of c to the d and log of d to the a. So how do you solve that? So taking a logarithm base 10, let's assume we take log of 10. So how will you go about it? So log of a, using this as this k is arbitrary base, we are assuming it to be a base of 10. So you will be getting this log of b to the power of log of 10a. Similarly, you will get here log of 10 into c and log of 10b, here log of 10d and log of 10 of c, similarly log of 10a and log of 10d. So obviously this will cancel it out, this will cancel it out, this again will cancel it out, and this again will be cancelled out. So all things will be cancelled out, and you will get the result as 1. So we have nothing done with this. Is not very complicated. Just think that we have to take any base. Let's say you could have chosen k, you could have chosen p as an arbitrary base, but we have to find a common denominator where we can just simplify it for our benefit. So again a question, given log of e x of 4 y is equal to a and log of e x square y is equal to b. So we have to find out log e root y. So this is the question. So how will you go about it? So you can see that these are two relations. Let's assume we have got two relations here and both are exponential base of logarithms. First you'll simplify this. Log of x is equal to y is equal to a. Now this is a multiplication. Obviously you will do great of doing this into this in your head. And log of, how will you solve it? So this comes here, it will be translated into log of ex, and now since you have broken it down, here is log of y, because this log of a into b is equal to log of a plus b. So obviously this will be simplified as a. Now we have got a second relation over here. So log of ex square plus log of ey is equal to b. So 2 of log ex plus log of ey is equal to b. So you can see here we got two relationship here. Now if we subtract these two equations, what we will achieve is a minus b, because this RHS side and this LHS is 4 minus log ex is equal to 2 log of ex. Since this will be cancelled out, so this is what we get. Then again, if we multiply here 2, now what is a minus 2b? If we multiply here 2, so what we will left is this 2 into log ex will be cancelled out with this. So a log of ey minus 2 log of ey. If we reverse this relationship, 2b minus a is equal to, we will be getting here log of ey. So we have two relationship here. So log of ey, 2b minus a, and 2b minus a is, substituting from here, you will get log of ey is equal to 1/2 of 2b minus a. This is what we were shifting, because and then we will go into solve log of e root y as required. So that will be, since this is y is equal to log of ey half is equal to half log of ey, and since log of ey is equal to 2b minus a, so log of 2b minus a. So this is what you will get, and this is the final answer to this. This was a redundant step over here. We could have skipped this relationship because we needed this log of ey, so we have to we have to leave with this term. We should not be cancelling it out. Ideally we should be cancelling this log of ex term, which is not required here because the relationship we wanted was log of ey. Now let's assume you have got another problem. Log of 2 is equal to 0.3010 and log of 3 is equal to 0.4771. So find log of 108. So log of 108 is equal to log of 108 raised to power 1 by 2. This 1 by 2 shifts here, and 108 is, it should be broken into the factors of 2 and 3. So log of 108 is equal to 2 raised to power 2, because 2 raised to power and 3 raised to power 3, essentially 4 multiplied by 27 plus 4 7. Yes, this is 108, 27 into 4. So half log of 2 square plus log of 3 cube. Again log of a into log of b is equal to log of a plus log of b. So 2 of log 2 and 3 of log 3. Since log of 2 is given and log of 3 is given, so 1 by 2, this is 0.3010 plus 3 into this 0.4771. So a bit of calculation. And you will land over here. So it is just a calculation part which I am skipping here. Okay, another example, another simpler way to perform this calculation is while you move 2 here. So 2 and 3 by 2 here move, then this. So another 2 by 2 is this log of 2, and what is remains is 3 by 2 of log of this. So another trick just to manipulate this problem in your favor. Whatever you feel like, you have to be a bit quick with mental calculations here. Now solve eight log 231. Let's assume this is y. So since this is base 2, you will be prudent enough, it will be prudent enough if you will write 8 is equal to 2 raised to power 3, hence 2 raised to power 3 log of 231. Again, since this is 3 and this is already in power, so you will be doing good if log of 231 2 of log 231, and you shift it the 3 here because This is at the exponent level, and 2 can be written as 2 raised to power 3. So essentially that 3 gets into an exponent side, and exponents can be shifted here and there. So again, what you will get is, since 2 log 2 31 raised to power 3 again. So again, this a raised to power a log a x is equal to, this is a logarithmic property, this is 1 raised to power x is equal to 1. So we will get 31 raised to power 3. So this is the problem. Another logarithmic problem with somewhat more complexity, 5 of log of 7x plus 3 into x log of 7 5 is equal to 1. You have to find here x, solve for x. How do you go about it? So we can apply a base change formula here for log of 7x, and we can, if we can take a base of 5, we will come explain why we have chosen 5, because we have here this 5 raised to power 5 will be making our life easier. So this is what we have chosen here. So essentially again, log of 5x, there was a property 1 of log of a b is equal to reverse of log of ba. So this is log of 5 7 log of 5 7, sorry, this is 5 7, so yeah, this will here be reversed, 7 5, this will be reversed here. So now this expression here, 5 of log 7x will be resultant of log of 5x multiplied by log of 7 raised to power 5 plus 3 into x log of 7 5 is equal to 1. We chose this log of this base as 5 because we wanted to make the basis same here. So again, this is at the power level, so 5 of log 5x, since at another example we said that the numbers at the exponent level can be this shifted 1. I will be writing this LHS side alone. So essentially now this will be, since this is 1 raised to power x, so this is our relationships. Now x to the power of log 7 5 is equal to 1 by 4. This is the relationship we arrive at, and finally Ex is equal to since this is 2 minus 2, so we will get this log of 2 minus 2 and 1 by log of 75. So this is further simplified to this log of and log of 57, because that while reversing the numbers, the shift and base and the number of logs changes. So this is the value of x, final value of x. A bit of this is a difficult problem. If you feel any difficulty, you can comment, ask me in the comment section. I will be more than ready to help it out. So that's all for part 1 of the logarithm section. We will join in the next session. Thank you very much, students.